Hopefully skydiving is on your bucket list. In order to skydive, you should be aware of the physics involved. Skydiving is much different than free fall. With free fall, you are in a vacuum. This means that there is no air resistance and you will continue to accelerate due to the force of gravity, which is 9.8 meters per second squared. This is not true in our world. When you are skydiving, you will eventually reach a constant velocity. This is due to our air resistance. This constant velocity, also known as equilibrium, occurs when the net force is constant. Besides air resistance, what is the opposing force acting on the skydiver? The force is weight. This force pulls you down as your velocity increases, so does the air resistance. When falling through the air, our acceleration will eventually equal zero.
This is calculated when the force of the weight is equal and opposite to the force of air resistance. Now what happens when you are either increasing or decreasing your surface area? Does this affect your force of air resistance? The answer is yes. When a skydiver reaches their terminal or constant velocity, they realize that they release their parachute. Their velocity changes. This is due to the increase in surface area. When the parachute is released, air resistance increases. Therefore, the skydiver's velocity decreases. At this point, the air resistance is greater than the force of weight. Therefore, acceleration increases in the opposite direction. Even though the air resistance initially increases, over time, net force will reach equilibrium once again. This occurs because the skydiver's weight remains constant and the force of air resistance once again equals the force of weight. Why does a crumpled piece of paper hit the ground before a sheet of paper now? This is because the difference of surface area. The crumpled paper is not being hit with as many air particles as the flat sheet of paper. Air resistance at its finest.